Hello and welcome to INE's CCI Service Provider version 5 lab course. My name is Rohit Pardasani, and for some of you who do not know me, I have 5 CCIs: CCI in Route Switch, CCI Security, CCI Voice, CCI Collaboration, and CCI Service Provider. So here today we will learn about OSPFv3 on Cisco IOS XZ and iOS XR. So here we will look at how do we implement OSPF version 3. Now configuring OSPF version 3 on a Cisco IOS router is pretty straightforward. There are 2 ways to actually do that. You could do that by going to the router and making configuration with router OSPFv3 command, or you could use the IPv6 router OSPF and the process ID. So 2 different ways of actually configuring it. They both are pretty much the same. So when you use the IPv6 router OSPF1 command as per this example, you're basically enabling just IPv6 and you're running OSPF for just IPv6. However, if you give the command router OSPFv3 and then the process ID 1. So the command is router OSPFv3 1. If you give that command, then that command supports both address families, IPv4 and IPv6. It's basically address family based. So you have one process running multiple address families inside one OSPF instance. So here in this example, I have router 1, which has been configured for IPv6. Obviously, IPv6 unicast routing is disabled by default, so that's the first thing you do. You activate IPv6 unicast routing. Once you've done that, you can now enable the OSPF process for IPv6. Remember, the router ID in IPv6 is an IPv4 address. It cannot be an IPv6 address. It cannot be 0.0.0.0 because that IP address is reserved. It has to be a legitimate IPv4 address. It does not need to have an active interface. You can just give any IP address as the router ID as long as the router ID is unique within your area. Then to activate OSPF is done by going to the interface. There's no network statement in OSPF. In OSPF version 3, there's no network statement. You go to the interface and you activate the IPv6 OSPF process. Now, implementing OSPF version 3 on a Cisco IOS XR is different from iOS XZ. iOS XR does not support running IPv6 router OSPF command. Instead, we run router OSPF version 3 command. Again, this supports only IPv6. It's not like iOS XZ, which supports address family IPv4 and IPv6. Router OSPFv3 is purely for IPv6. Router OSPF is for IPv4. So again, here you would set the router ID, you would define the area and activate the interface, which should be in area 0. Verifying OSPF adjacency is pretty similar to verifying OSPF adjacency on when you're running OSPF version 2. So the command is, instead of show IP OSPF neighbor, you would give the command show IPv6 OSPF neighbor. Similarly, verifying adjacency on a Cisco IOS XR-V is again pretty similar to verifying on OSPF-v2 on an iOS XR-V. So the command is show OSPF-v3 neighbor. Again, you would see all the list of neighbors. If you have a broadcast segment, then you would also see whether it's a DR or the neighbor is a BDR. Now, you can also verify your OSPF-v3 database. So it's different from OSPF version 2. Now in ISIs, we can have multi-topology being run so that we have ISIs version 2 database and ISIs version 3 database. So basically for IPv4 and IPv6. But in OSPF, there are 2 separate databases, one for IPv4, one for IPv6. So verifying the database is show IPv6 OSPF database versus show IP OSPF database, which is for IPv4. Again, as far as the LSAs are concerned, they are pretty much similar to IPv4. You'll still see your router LSA, you'll still see your network LSA. If you have inter-area, you would see the summary LSA or ASBR summary or external LSA. Verifying OSPF database on iOS XRV, the command is pretty much the same, show OSPFv3 database. Finally, the routing table is show IPv6 route OSPF, which is on iOS XZ, and on iOS XRV, you would see the command would be show route IPv6 OSPF. So let's in fact go and implement this. We would go and actually configure two routers to run OSPFv3. We'll have some IPv6 addresses, maybe the loopbacks on router 1 and maybe on router 2. Or in fact, let's take one iOS XZ and one XRV so that we see both the flavors. And we would have some loopbacks which has IPv6 addresses and they would exchange routes with each other. Alright, so I have R6 here which connects to XR1. And if I look at the interface, it has basically an IPv4 and an IPv6 address. Let's do a show run interface gig 1.619. As you can see, I have an IPv4 and an IPv6 address. Similarly, on XR1 show run interface, you would see that I have an IPv4 address and an IPv6 address on my interface gig 0x0x0x0.619. Now, both these routers, they are able to reach each other as they are back-to-back connected. However, I'm not running any kind of routing protocol at this point of time. Let's run OSPFv3 on these routers and see if they can establish adjacency with each other, at the same time learn each other's routes. So I'll start off with router 6 and do IPv6 unicast routing. I'll in fact show you both the methods, the OSPFv3 versus the older method of running a separate IPv6 process. So IPv6 unicast routing, then we do IPv6 router OSPF1, and finally we define the router ID, which should be unique. So let's give this as 6.6.6.6. And then finally, I activate OSPF under my interface. So that's going to be under interface gig 1.619 and say IPv6 OSPF1 area 0. This is one way of doing it. Let's also activate on the loopback, which is IPv6 OSPF1 area 0. So now I have IPv6 running on router 6. Let's go to XR1 and run OSPFv3 on XR1. Now, if you remember, I told you that in XR1, the router OSPFv3 command is different from iOS XZ. In iOS XZ, it was address family based. It supports both the address families. But on iOS XR, the router OSPFv3 only supports IPv6. So router OSPFv3 process ID 1. Let's define the router ID to be a unique router ID, which is 19.19.19.19. And then address family, we have IPv6 only. So IPv6 unicast. And then finally, I define my area 0, and activate for my loopback and also for the interface gig 0.0.0.619. The minute I say commit, you would see that I have an OSPFv3 adjacency with router 6, and he should learn the loopback of router 6. Let's in fact verify that. Let's do a show route IPv6 OSPF. I should see the loopback of router 6, which I can. If I do a show OSPFv3 database, you would see that I have my router LSA, I have my network LSA, I in fact see LSA type 8, and I also see intra-area LSA in case if I did have some intra-area routes. Now, if I had to run OSPFv2, I had to run that separately on iOS XR. So let's in fact run OSPFv2 also. So that's going to be done by doing a show run router OSPF. Let's check if it is already pre-configured. So I already have some OSPF pre-configured on routers on my iOS XR, which is probably running OSPF with R6. So let's do a show OSPF neighbor. Let's exit out and do a show OSPF neighbor. So I'm not forming adjacency with R6 at this point of time. Maybe R6 is not configured. Let's check that. So since I ran the command IPv6 router OSPF, that's only for IPv6. So if I have to run IPv4, I have to run that separately with the command router OSPF1 and then define my router ID 6666. And then under my interface gig 1.619, I would say IP OSPF1 area 0. So if you actually look at my interface, you would see that I'm running IPv4 and I'm running IPv6. So let's do a show run interface gig 1.619. So I have IPv4 and IPv6. Again, I would not establish neighborship at this point of time because I think XR1 is configured for authentication. I will go and remove that authentication from the process so that we only do normal OSPF adjacency. So router OSPF1, area 0, and then interface. I would remove the no authentication message digest and let's do a commit. So I should now establish OSPF adjacency with R6. So I have two separate OSPF process on both the routers. XR1 is running a router OSPF1 and router OSPFv3. One for IPv4, one for IPv6. Similarly, R6 is also running two separate processes, one for IPv4 and one for IPv6. Now this may not be desired sometimes because sometimes you may want to run separate address families, or sometimes you may want to run just one process with multiple address families. So in that case, you can do router OSPFv3 on iOS XZ. That is address family based. You cannot do that on iOS XR, but on iOS XZ you can. So if I actually just go back and change that, I could go and say router OSPFv3, let's say process ID 10, and here I can define address family and I can activate IPv4 and IPv6. So like you see that running OSPF version 3 is pretty straightforward. As long as you know how to configure OSPFv2, it's pretty much the same command, is just v3 instead of v2. I hope this video was informative to you and thank you for viewing.